Okay, linear programming. You're probably tired of doing these. Don't worry, I am too. But nevertheless, I've got two more examples for you coming today. I'm going to do this Georgia Super Sports one and then one other one. These two in my class you're doing on Friday. And anybody else who's watching the video, just find it in your notes. Okay, so the first thing you always do is you read through the problem and circle everything that's important. It says the Georgia Division of Super Sports produces footballs and basketballs. Okay, it takes 4 hours on machine A and 2 hours on machine B to make a football. Producing a basketball requires 6 hours on machine A and 6 hours on machine B. Machine A is available for no more than 120 hours per week, and machine B is available no more than 72 hours per week. If the company makes $3 profit for each football and $2 profit for each basketball, then how much would maximize profit? So I've underlined everything important. I've kept all the football information in purple, all the basketball information in pink, and then the totals that are about both of them, machine A and machine B, I just put in black. So as I said before, the first thing that you always do is you create your profit function, okay? If I'm writing my profit function, I'm trying to find what has to do with money. So what numbers in my problem have to do with money? $3 profit for each football, $2 profit for each basketball. That helps me know what my variables are. So 3x plus 2y equals profit. Now, if that's my profit function, then that means that x would equal footballs and y would equal basketballs. Okay? One more time, I'm going to pause. Profit is about money. You go into the problem and you read, where is their money? $3, $2. Both of those have to do with money. Because they have to do with money, that means that my variables are football and basketball. Your variables are always coming out of your profit function. Moving forward, I like to create a list. I'm going to create a list of everything that has to do with football and everything that has to do with basketball. Okay, so I'm going to read through the problem, and anytime I got a number or something that I circled, I'm going to put it in my list. So, starting again, it takes 4 hours on machine A and 2 hours on machine B to make a football. So 4 for machine A, 2 for machine B. Basketball requires 6 on machine A and 6 on machine B. Okay, I've separated it by football and basketball. Now, when you get to this sentence that says machine A is available for no more than 120 hours, that would be a total. So no more than 120 is machine A. That has to do with both basketballs and footballs, so I'm going to put it off to the side. It doesn't just have to do with one of them. Then my next part, machine B is available for at most 72 hours. Again, I'm going to put that off to the side because machine B has at most 72. The last piece of information from my circled problem is $2 and $3. Okay, every single thing that I circled is now on my list. The list is where your inequalities or your constraints come from. If you look across your list, okay, we've got X and we've got Y. We've already used the $3 and the $2, so I'm going to cross those out. All of your inequalities come from totals. These are your clues about what your inequalities must be about. Okay? If I have a total of A machine, then I need an inequality about all of the A's. So if you look across the top row, we've got 6 A's for football, 6 A's for basketball, and it has to be no more than 120. I'm going to translate that into an inequality. So 4x plus 6y is no more than 120. So one more time where you can see it. 4 footballs, 6 basketballs is no more than 120. I'm going to do the same thing with all my b's. 2 footballs plus 6 basketballs is at most 72. Now I have officially used every single thing from my sentences. The last thing that always has to be included is a lower limit. If you don't have a lower limit in your problem, which we don't in this problem, you always have to include that y has to be bigger than 0 and x has to be bigger than 0. These are the two things that students miss because it has to come out of your own brain. There's nothing in the problem that clues you in to that. So if there's ever a lower limit, meaning like, hey, it has to be more than 3 or more than 4, then you're fine. You don't have to include this. But think about it. You can't make negative amounts of things, so you always have to have y is greater than 0 and x is greater than 0. And that creates your other two boundaries that helps you make your shape. So I'm going to pause this video, and I'm going to rewrite these equations so that they're ready to graph in y equals. And then I'm going to create a scale on my graph also. Now this goes to 120 and this goes to 72, so I might have to scale my graph a little bit, but we'll figure that out once I rearrange it. So pause the video and rearrange these formulas so that you can get ready to graph. Okay, my screen shifted a little bit because I needed to be able to see my graph now. So down here I solved my problems for y, and I solved this one for y. So my inequalities are now ready to graph, okay? Now, if this goes up to 20 and this goes up to 12, I can probably just count by ones, okay? So I'm going to create my scale. Okay, so I left off with making the equations, and I told you that you should count by ones, but I did the whole problem, and you can't count by ones because it messes you up on your x-axis. So we're going to count by twos instead. So this is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then I got to go 2, 4, 6, 8, 10, 12, 14, 16, 20. Okay, so anyhow, this is good because when we count by twos, I want to show you something about the slope. So I'm going to count it starting at 20. Okay, because this is 20. Now when I count down 2 and over 3, I don't actually care about the numbers. I want you to count based on boxes. Because what happens is if you simplified the numbers, you would still get to negative 2/3. So if ever you're not counting by ones on your graph, don't worry about it. Count by the numbers in your boxes. Okay, so I'm going to count down 2 boxes over 3 boxes. Down 2 boxes over 3 boxes. Down 2 over 3. Down 2 over 3. Down 2 over 3. Your x-intercept should be at 30. Now, just make sure that every point is on a corner. Okay, I'm going to connect them. And if it's less than, I'm going to be inside this triangle. Okay, graphing the other one, I start at 12. Count down 1 over 3. Down 1 over 3, down 1 over 3, until I find my way down to the bottom. Okay. Again, I'm graphing below this line. So we're in this box. Okay. Now I've got x is 0 and y is 0, which makes the other corners of my box. So this is kind of like a triangle with a little bit of cutoff. So I'm going to circle all my corners. Okay, so once I have my corners, I got 0, 18, 24, 4, 30, 0, and 0, 0. Those are from the four corners of my shaded region. These are all the possible choices that I have to maximize my profit. Maximizing profit means that I need to make the most money. So either making 0 footballs and 18 basketballs makes me the most money, or making 24 footballs and 4 basketballs makes me the most money. 30 footballs and 0 basketballs. 0, 0 is going to get me no money. So I don't ever actually plug that one in, because a profit of 0 would be 3 times 0 plus 2 times 0. So I'm going to plug each one of these into my profit function, which is right here from above, putting the x in the x place and the y in the y place. And then I'm going to compare which one of these is going to give me the most money. So if you plug these in, you should get, hold on, let me get my calculator. 3 times 24 plus 2 times 4. $80. 3 times 30 plus 2 times 0. $90. 3 times 0 plus 2 times 18. $36. So my sentence at the end would be, the maximum profit is $90, which uses 30 footballs and 0 basketballs. Now, if there's any part of that that you don't understand, then rewatch it. Max profit of $90 when you make 30 footballs, because footballs was X, and 0 basketballs. Okay, I got one more for you coming in a minute.